Hi guys, welcome back to my channel. And yeah, if you are new to my channel, please consider subscribing. And because yeah, there's a lot of information that I'm going to be releasing over the next few weeks. So yeah, just to help you guys to prepare well for these upcoming exams. And yeah, I would love to hear your comments and your questions about the stuff that you're struggling with the most, so that I can make the videos on those sections. So yeah, in today's video, we're going to be looking at the functions. So previously we discussed quadratic functions and we discussed the hyperbolic functions. So now we need to see how we can apply those concepts in the context of the exam questions. So yeah, I'm going to divide this video into two parts. So one is that we're going to look into applying the concept on hyperbola for November 2021 paper and 2020. And then the second part of the video will look into applying those concepts on the on the quadratic functions. So yeah, without wasting time, let's get to the content of this video. So if you allow me to share my whiteboard so that we can get started. Okay. Yeah, so the paper that I want us to look at, so as I said, it's November 2021 and November 2020. We're just going to look into hyperbolic equations. And then from there, we're going to discuss the questions on the quadratic on the same paper, just to see how they ask these questions in exam, because it's very important to be able to apply the concept in exam questions so that, you don't struggle. Okay, so yeah, I think we can start with November 2021. So if you look into the zoom in, just to get to the questions. Okay, so yeah, what I've noticed is that the reason why I focus mainly on the quadratic functions and the hyperbolas is because I've noticed that in most of the exam questions, like they ask this a lot, right? So if you really understand them and you master them, then I think you will get easy marks, right? Because the questions are very straightforward if you understand the concepts. Okay, so let's look into November 2020. So the paper was, the hyperbola, the first function question was on question 5. On this question, so you were given a hyperbolic function f of x there. And then the question asked you to write down the equation of asymptote. That was the first part of the question. Write the domain, determine the coordinates of intercepts, and then they wanted you to draw a graph, right? So remember, as I've mentioned previously, it's very important that, when you see, when you see that, you're dealing with a particular function, to try to recall all the information that, you've learned for that particular function at the back of your mind, because it allows you to answer the questions much quicker, right? So you don't have to think hard about these concepts, right? So remember, we mentioned the hyperbola as a function of the form y equals to a over x plus p plus q, right? So this is the form of what hyperbolic function that we have learned in the video. Please visit the link down below. And we mentioned that the value of a is very important for telling us the shape of the graph. Remember, the hyperbolic graph is always either in the first quadrant and the third, or the second and the fourth, right? Depending on the sign of a. So if a is positive, first and the third, and otherwise second and the fourth. And then so we also discussed that, p it's like, a vertical, x equals to minus p is equals to like the vertical asymptote, and then line y equals to q is equivalent to horizontal asymptote, right? So already, by knowing this form, you should be able to already answer most of this question here, right? So let's look into these questions. So they wanted us to determine the equations of asymptote of f, right? So if we remember, we know that. So equation of asymptote is equals to x equals to minus p and y equals to q, right? So all we need to do is look into our equation. We need to look into our equation and then derive these values. So if we look into our equation, we can see that, we can see that P in this form, the P is equals to minus 3, right? And then Q equals to 2. So which means then that the equation of asymptote for this graph, so for 5.1, then the answer is, remember our function is in the form minus 1 x minus 3 plus 2, right? So which means that x equals to minus 3. That's first equation of asymptote. So that's a vertical asymptote. And then a horizontal asymptote is going to be y equals to 2, right? So which equals to 3. So then, yeah, there you go. You already have your 2 marks for the first part of the question. Okay, so let's look into the second part of the question. So they said determine the domain of f. Remember, the domain is set of all x values that the graph can take without being undefined, right? And if you remember from our previous video, we mentioned that the domain for hyperbola is always x is element of all real numbers, but x cannot equals to minus p, right? So in other words, x cannot be asymptote. So in this case, our p is minus 3, so meaning that the domain for this function for 5.2, the domain is going to be x is element of all real numbers, but x cannot equals to cannot equals to 3, right? Because it's going to be minus 3, which is our asymptote. Okay. So yeah, you can see like these questions are very straightforward, eh? If you understand the concept. So then they say determine the coordinates, the coordinates of x-intercept and the coordinate for y-intercept. Right? So remember the basic principle for finding the coordinates is if you're finding x coordinates, we always let a function of x equals to 0, because at that point the y value is 0. So that's why we let it equals to 0. And then for finding y-intercept, we have to let x equals to 0 and solve in our equation, right? Okay, so let's get those coordinates quick. So 5.3. So so we're gonna say let f of x equals to 0 for what? For getting x-intercept, right? X-intercept. Okay, so what is f of x? Remember, I'm just gonna write it on the side here. Our f of x is given by minus 1 over x minus 3 plus 2, right? Okay, so which means then we're gonna let that f of x equals to 0. So we're gonna have 0 equals to minus 1 over x minus 3, sorry, plus 2, right? So there's a couple of ways of solving this. So one way is to take 2 to the other side and cross multiply. So if we do that, then we're gonna have minus 2 equals to minus 1 over x minus 3, right? Okay, then what we need to do is cross multiply. So if we cross multiply, so we're gonna have minus 2x minus 3 equals to minus 1, right? So we can divide by minus and you just get rid of the minuses there, then multiply within the brackets, then you're gonna have 2x 2x minus 6 equals to 1, right? So which means then this implies that 2x equals to 1 plus 6, right? So therefore x equals to 7 over 2, right? Which is equals to 3.5. Okay, so now we have x value of what? Of x-intercept. So then the coordinate, remember, is always gonna be that value in 0, 3.5 and 0. Those are your coordinates. Okay. So then, yeah, the second question is or the second part is to get the y-intercept, right? Is to get the y-intercept. So y-intercept, to get it, we just let y equals to 0. So if we substitute, we let x equals to 0. So f of 0 equals to minus 1 over 0 minus 3 plus 2, right? So this will give you minus 1 over minus 3, that gives you 1 over 3 plus 2, right? That's the answer. So this is equivalent to saying, so if you multiply by 3 over 3, so this is the same as saying 2 over 3 essentially. Okay, I mean to say this is the same as, actually I'm running out of space. So yeah, this is the same as 7 over 3 essentially. This is the same as 7 over 3. Okay, because just multiply this on the 2 by 3 over 3, that gives you 6, then plus 1, then that gives 7 over 3. Okay, so which means then your intercept then is gonna be so for this guy it's gonna be 0 and 7 over 3, right? And then this one is minus 3 over 5. Let's go back to our whiteboard to confirm. So, yeah, okay, it's 0.5. So it's 0.5. So that's 3.5 and 0. Those are your coordinates, right? Okay. Yeah, so then the last question is for you to draw a graph, and then they say clearly show all the asymptote intercept with the axis. Okay, let's draw a graph. So the graph that you need to plot for, so let's write the equation on the side so that everyone is clear. So the function is f of x equals to minus 1 over x minus 3 plus 2, right? Okay. Okay, let's just write this technique. Okay, so yeah, so we know that our graph, so we need to draw. Okay, so this is x-axis, this is y, right? Okay, and then we need to plot our asymptotes. Remember, asymptote equals to x equals to 3 and y equals to 2, right? Those are line of asymptote. So x equals to 3. So okay, so this is 3. Okay, this is 3. Let's say. Okay, let's just say right x equals to 3. Okay, just yeah. Okay, and then okay, then we need to draw a horizontal one, y equals to 2. Y equals to 2. Okay, y equals to 2. That line there. So y equals to 2. Y equals to 2. Okay. So remember we said that depending on the sign of A, right, in your equation, whether it is positive or negative, that will tell you whether your graph will lie on the first or the third. Remember the quadrant that we're talking about is those that are made by the asymptote, not the ones that are made by y-axis and x. x-axis. So in this case, our A is negative. A is negative. So if A is negative, it means that our graph is going to be on this quadrant and this one, right? So then, yeah, we're expecting, okay, remember we also need to show the intercepts. Yeah, so we need to show those intercepts as well. So our graph is going to cut here at 7/3, right? So this is 7. Remember, this is our y-intercept. And then our graph is going to cut x-axis at what? 0.5, right? At 0.5. At 0.5. So 0.5 is somewhere here. Okay. Okay. So we know that our A is negative. So our graph is going to be on the second and the fourth quadrant. So we're expecting our graph to, remember the graph can never touch lines of asymptote. So our graph is going to be something like this. Okay. Okay. Then this side is going to be something like this. Okay. Yeah, essentially this is your graph that you will have drawn. The key important point is that the sign of A is important for tell you the quadrant in which your graph they will be in. The lines of asymptote are very important, to show them so that you show that your graph is not going to touch those lines. And then also it's important to show what those intercepts that you've calculated there, right? This is 0.5 and 0, right? And that's 0 and 7.3. I mean 7/3. Okay, yeah, that's the end of the question, essentially. Okay, now let's look into November 2020 paper. Let's see what they were asking there. So if we look into November 2020, so yeah, November 2020 question, like they also gave you the hyperbola in that form, in a standard form. So from that, you should already know that, okay, so by just looking at that, you should already be thinking that, okay, A is less than 0, it means your graph is going to be in this quadrant, right? It's going to be this guy and this guy, right? You should be thinking about that. Okay, and then so you are given that x equals to -1, so you should be thinking that vertical asymptote equals to x equals to -1, right, which is 1. And then you should be thinking that your y asymptote is going to be y equals to 2. Okay, so already you're solving the question by just looking at the standard form before you actually even answer the question. Okay, so yeah, now let's look at the questions that they've asked us. So they say write down the equation of asymptotes. So this is very simple. We've already established that. So equation of asymptote is equals to x equals to 1 and y equals to 2, right? So yeah, because remember, I just keep repeating this, but it's very important. It's equals to minus p. That's your vertical asymptote, and then y equals to q is your horizontal asymptote. These they all come from the standard form, right? Standard form that we've discussed: x plus p plus q. Okay. So yeah, those are easy 2 marks. So, and then they say determine the equation of axis of symmetry of H that has a negative gradient. Okay, this is very interesting. Remember, we mentioned that there are 2 lines of asymmetry for hyperbolic functions. So one of them has a positive gradient and one of them has a negative gradient, right? And then we mentioned that the equation of each, so it's either you can have the one with, y equals to x plus c1, right? So this is the one with the positive gradient, right? Or the one where you have y equals to x minus x, sorry, plus c2, right? This is the one with the negative gradient. So they're asking you to get the equation of this, like the equation for this. So already you know the gradient because you know this, they meet at 90 degrees and the other one has a +1 gradient and the other one has -1. So in this case, you already know the gradient. So all you need, you just need 1 point. You just need 1 point on the graph, right? You just need 1 point on the graph that can allow you to find the value of what? The value of the value of C2. Okay. So what you can determine the equation of axisymmetry of H. Okay, write down the equation of asymmetry of H, right? So they say determine the equation of the axis of asymmetry of H that has a negative gradient. So we know these lines, so equation of symmetry. So okay, so you have so this is 2, okay, and then this is like 1, right? And then this equation, so the one that they're talking about is the one that goes through here, right? It goes through this point. It passes through this point, right? Okay, so and then the other one goes this way, but there we are looking for this one here, right? So yeah, what we need then is to use this coordinate. This coordinate is the where our asymptotes they meet, right? So that's what you're gonna have to substitute for this guy and this guy, so that you solve for C, right? So we know x here, x equals to 1 because it's a y. It's the vertical asymptote, and then the y equals to 2 because it's a horizontal asymptote. So if you substitute 2 and then you substitute my 1 here, then you can solve for C2, right? Therefore, which implies that, so if you take this to the other side, then C2 equals to 3. Okay. So then, after this, then which means we will have found our equation that they're looking for, right? We will have found our equation that they're looking for. So the equation that they're looking for then is gonna be y equals to minus x plus 3, right? So, and if we look into this equation, it should make sense to us in the sense that, remember, this is the line. Like, so if this is 2, and then like it has to cut somewhere above 2, right? So C of 3, it makes sense in this context, right? C of 3 makes sense in this context. Okay. Then yeah, the last question said sketch the graph of H showing the asymptote and intercept with the axis. So this is just a repetition of the previous question that we've seen, except that the form of the function is different and the values. Okay, so let's try to plot our graph. So our graph is given by y equals to minus, I think it's minus 3. Let's just verify that. So yes, minus 3 minus 1 over 2. So minus 3 minus 1 over 2. So it's minus 3 x minus 1 plus 2, right? Okay. So we need to plot this. So we already know that the vertical asymptote equals to x equals to 1, horizontal asymptote equals to y equals to 2, right? And then they ask us to show, I think they said you should also show the intercepts. So we need to work out the intercepts. So let's just check. They said, yeah, show the intercepts with axis, right? So we need to work out the intercepts. Before we can plot the graph. So remember for y-intercept. So for y-intercept, you're gonna find, this is the same as h of x, right? So for h of 0, so if we let x equals to 0, then you're gonna get answer for minus 3 over 0 minus 1 plus 2, right? So that give us minus 3 over minus 1, that's 3 plus 2, that's 5. Therefore, which means our graph y coordinate is going to be 0 and 5, right? That's y-intercept. Okay, so for x-intercept, so I'm just going to work it out here. I'm just going to use this space for drawing a graph. So yeah, for x-intercept, so we're going to have to let h of x equals to 0. So if we do that, then you're going to have 0 equals to minus 3 over x minus 1 plus 2, right? Okay, so then now we take 2 to the other side. Then we have minus 2 minus 3 over x minus 1. Then yeah, we just cross multiply. Then you're going to have minus 2 x minus 1 equals to minus 3. Okay, so then that means then we need to, if you divide by negative both sides, then you're going to have 2x minus 2 equals to 3, right? So, and then 2x equals to 5, because you take 2 to the other side, then x equals to 5 over 2. Okay, then the x coordinate is going to be 5 over 2 and 0. Okay, so yeah, now we have the coordinates, right? We have the coordinates, and then we have the asymptotes. So let's draw the graph. Okay, so yeah, our graph is going to be x is equals to, this is x equals to 1. Then we have this guy here. Okay, that's y equals to 2, right? Remember, always label your x's, because this is where some students, they lose marks. Okay, and then so we know that a is negative, so our graph is going to be in the second and the fourth quadrant, right? So then our graph, and then remember the graph, the y-intercept is given by, 5. This is 5. So our graph is going to be, like this. It's going to cut at 5. And then the x-intercept, that's given by, let's go back. So that's 5 over 2, that's 2.5, right? So 2.5, let's assume is somewhere here. Then our graph is going to be like this. Okay, yeah, then that's just simply what they're looking for. Yeah, I mean, that concludes the end of our questions that, I wanted to share with you. Yeah, I hope you found this very useful and you feel confident about how those concepts that we've discussed, they apply to exam questions. So yeah, if you feel like, you struggle with any particular question that maybe you might have attempted from the class or in one of the past papers that you want me to do a video on, please do let me know. And yeah, I'm happy to discuss them with you. And yeah, please don't forget to give me your comments and the questions that you might have on these sections that you've discussed. Yeah, looking forward on the next video where we discuss the quadratic function exam questions. Okay, see you next time. Cheers.